Drag reducing agent, or DRA, is a pivotal product in the oil and gas midstream sector that is injected into pipelines to ensure on specification product while reducing energy costs by decreasing friction that occurs in pipelines. While its importance is undeniable, DRA is costly, with some companies spending millions of dollars on it quarterly. Despite this cost, the consensus in industry has been that it's better to be safe than sorry and inject DRA liberally along the segments of pipelines. As more data becomes available about our process, Seeq serves as a great way to not only view this data, but also optimize DRA usage based on it, potentially resulting in millions of dollars of savings. A Seeq customer previously tackled this use case and documented their workflow using Journal. We'll use this journal to step through their analysis, where they began by trending tags relevant to their pipeline. This data came from an asset tree developed using Seeq Data Lab. Seeq Data Lab is Seeq's Python interface that empowers engineers to leverage the vast possibilities of Python without needing to be fluent in it. With this asset tree, we'll be able to not only easily access the tags we need, but also scale our analysis to other pipelines. One consideration the engineer had to account for was pipeline flow regimes. Operating at different flow rates could produce differing pressure responses along the pipeline, so they wanted to focus on a particular subset. Using Seeq's value search tool, they were able to identify when they were operating within the filter band and can then limit the analysis to only be based on data during it. With the data cleansing complete, the engineers shifted their analysis to determine inefficient DRA usage based on an operation during this filtered window. They determined which segment had the lowest hydraulic room and aggregated this to generate a monthly bottleneck percentage for each segment. They also included other KPIs that give more insights, such as monthly average hydraulic room and average DRA flow for each segment. Overall, the table gave them a way to see across all segment areas where they may need to inject more DRA. For example, in this table, segment 2 is often the bottleneck, but its DRA usage is much smaller compared to other segments. By injecting more DRA, overall throughput could be increased thanks to segment 2 no longer being a bottleneck. Similarly, they developed another table to highlight when they were injecting too much DRA. This time, rather than reporting which segments had the least room, they showed which segments had the most room within a pipeline. If a segment consistently has a large amount of hydraulic room, but is still having a significant amount of DRA being injected into it, there was an opportunity to reduce the injection and still maintain desired operation. Both of these tables, when combined, can serve as a dashboard through which pipeline operators can decide on where to optimize DRA injection. To aid in the development of these insights, other datasets like pricing data, hydraulic models, and energy consumption metrics can be added to determine the cost benefits of changing this DRA injection rate. Seeq's ability to connect to disparate data sources allowed the customer to have the data aggregated in one location to provide a comprehensive overview of their process. Lastly, the engineer developed a tree map, which allowed them to monitor DRA usage across their pipeline fleet. Here, they used the KPIs developed in the previous tables to highlight conditions for when DRA usage is suboptimal. The different color indicators show severity, allowing the engineer to know which segment they should investigate. All this information was then included in an organized topic to have one central location to review all the analytics developed in this use case. This topic could be set to automatically update and be attached in an email, allowing other people besides the engineer to leverage it. Thanks to Seeq's connectivity and monitoring capabilities, customers have been able to save millions by optimizing their DRA usage.